I'm going to go over section 3.2 in this online video. And 3.2 starts on page 14 of your course packet. So you want to definitely have that available to you. If you haven't bought it yet, it's at the bookstore. We're going to talk about measures a center today. So when we say measures a center, we really mean just a typical value. And there's a couple different ways where we could calculate a typical value. So maybe we have measurements on female weights, and we want to know what a typical weight is for a female. We might calculate the mean or the median for that particular data set. So we're going to go over the mean first. And we calculate the mean by taking the sum of all the values divided by the sample size, which is the number of values. We denote mean with the bar notation. And so when you see a X or Y letter with a bar over it, that means that's the mean. The sigma notations means the sum, so we're taking the sum of all the values. And we're dividing it by the sample size, which is the number of observations. Okay, so we're gonna, you might want to do that on your TI calculator. We're also going to do that using StatCrunch, but at first we're going to do this by hand. So we're going to go over this example where we have ammonia fluxes from a stream after Hurricane Hugo. We have 10 observations and we want to calculate the average or the mean. So I'm going to denote it X bar. And that's going to be equal to the sum of all the 10 numbers. So I'm going to take 96 plus 66 all the way up to 154. And then I'm going to divide that by my sample size. We have 10 observations, so that's my sample size. And so that's going to be equal to 120. And I want to put units on there. That's kilograms per hectare. Okay, so the average ammonia flux is 120 kilograms per hectare. And that's how we calculate the average of something. The next thing I'm going to demonstrate is the median. The median is simply the middle observation. So by definition it means that half of the observations are less than the median and half of the observations are more. It divides the data set into two equal halves. And doing it by hand is pretty simple, but it's slightly different for an odd or an even number of observations. So I'm going to demonstrate both. I'm going to start out with the same data set, hurricane data set, and so we have an even number of observations. We have 10 observations, so if I split that into half, I can do that in my head, but that's just 10 divided by 2, so 5. I want 5 observations on both sides, so I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so this is where it gets split into two halves, and we want to come up with an actual number. So what we do is we take the average of these two observations. So we take 116 plus 147, and we divide that by 2. That gives us 131.5. Okay, so I'm going to put 131.5 here. And that's kilograms per hectare. And that's the median of those observations. Again, you can do this on the TI calculator. The next video is going to demonstrate that. So that was an even number of observations. Now we're going to do an odd number of observations. So here's a different data set where we have horsepower of 7 different rotors. And we have 7 observations. And so to get the median, I take the number of observations plus 1, divide by 2. And that's equal to 4. So the 4th observation is the median. So I count 1, 2, 3, 4. That's going to be my median. It's the 4th observation. And so I can check to make sure it is the median. I have 3 observations below the median and 3 observations above the median. 3 and 3. Okay, so that is the median. And the other two measures of center that we're going to discuss that are less common are the mode and the mid-range. The mode is very easy to calculate. There's really no calculation. It's just the most frequent occurring observation. And the mid-range is the smallest plus the largest divided by 2. So we're going to go back up to the previous data set and get the mode and the median. I mean the mode and the mid-range. So the mode's the most frequent, and 2.25 occurs 3 times, so that's going to be our mode because no other number occurs that often. And then the mid-range, I'm going to take the smallest, and this is an ordered data set, so 1.5 plus 2.25 divided by 2. So 1.5 plus 2.25 divided by 2. And this gives us 1.875. Okay, so I'll go ahead and fill in the blank there. So our mode was 2.25. And our mid-range was 1.875. I'm not sure what units are for horsepower, but you would want to put the units on there. So you may ask, well, when do I use the mean and when do I use the median? And a lot of times it's appropriate to use both or just pick one. But if there's a lot of outliers, which are small or large values that are far away from the rest of the data, so for instance, if someone was 7 foot tall, that would be probably an outlier with respect to height. In that case, the median is more appropriate. I'm going to demonstrate why that's the case. So let's go back to the hurricane data set. And we already computed the mean as 120, and we computed the median as 131.5. But now we're going to just say, well, maybe the 175 actually was recorded as 17,500. Okay, so maybe that was an error, or maybe there was really a stream with that high of ammonia influx. Okay, so we're going to recalculate the median and the mean based on the new data value. So the median is still the middle number. So here I have 5 observations on both sides, and I'm going to take that average of those 2 observations. And so that's not going to change. That was 131.5. And that doesn't change from what we had. But the mean, remember, is the sum of all the observations. So I'm going to sum these values up. So that mean is going to be quite a bit higher because my last number in the sum is 17,500. And so if I do that, I get for a mean 1852.5. So you can see the mean was really affected by an increase of just one value. In fact, the mean is larger than 90% of the data. So the median stayed the same with that outlier, but the mean increased. It got pulled toward the outlier. And because of that, we say that the mean is sensitive to outliers, and the median is resistant to outliers. Okay, the median didn't change at all, and the mean increased quite a bit with just one number change. That means the mean is much more sensitive to outliers. So if you have a data set with a lot of outliers, then the median is more appropriate. That's why when we report salaries or housing values, a lot of times we report the median and not the mean. Okay, and just one last thing. We're going to go over what happens to the mean and median with certain distributions. So the normal distribution, the mean and median will be approximately the same. For a skewed right distribution, that's a distribution that looks like this. The tail is on the right-hand side. The mean will be larger than the median, and that's because the mean gets pulled toward the outlier. So a similar thing as what happened up here. The mean increased where the median didn't. And then the opposite for skewed left. The mean is going to be smaller than the median.